Okay, let's jump right into this explainer. If you're a community leader, an LGU decision maker, or a disaster resilience planner, well, you already know the stakes. When a crisis hits, communication is absolutely your lifeline. But what happens when the very systems you rely on just vanish exactly when you need them most? Today, we're unpacking a massive paradigm shift in how we build, deploy, and fund local digital resilience. We are moving far away from fragile, cloud-dependent apps and stepping into a robust, locally sustained digital utility called Project Bantay Bayan, or PBB. Here's our roadmap for today. We're going to cover what happens when the internet fails, dive into offline first resilience, break down the three-machine standard, talk about daily readiness, and finally, look at the actual ROI of a digital utility.
Section 1. When the internet fails.
We have to start by confronting a really dangerous assumption. This belief that internet connectivity and cloud access will just always be there during a disaster. Because as we've seen time and time again during typhoons, floods, or power outages, that assumption is flat out wrong. Most emergency platforms sit entirely in the cloud, right? So when a typhoon knocks out the cell towers, those systems go totally dark. Citizens end up resorting to fragmented, chaotic social media posts, assuming they even have a signal at all. But the PBB local node completely flips the script. It brings the core infrastructure physically right into the barangay. If the broader internet dies, the local PBB Wi-Fi still works. Citizens can still submit structured reports to the local operator, and the barangay can still coordinate its response. The network survives because it's literally right there in the community.
Section 2. Offline first community resilience.
Now, this next concept is a total game changer. We're shifting away from the idea of just having an emergency app to building daily community infrastructure. We're moving beyond digital tools that just sit on a shelf gathering dust, waiting for a disaster. PBB helps communities stay connected, informed, served, and coordinated, online or offline. By turning PBB into an offline-first platform, we aren't just solving the emergency problem. We're actively bridging the digital divide for underserved areas. We're taking essential services like health scheduling, learning modules, and community chat and making them available locally. And the best part? We're doing it without forcing citizens to spend their precious mobile data.
Section 3. The three-machine standard.
Moving on to execution, let's talk hardware. You might be wondering, hey, can't we just run this all on one cheap mini PC or a Raspberry Pi? Actually, scratch that. For a real, breathing community, that is a massive operational risk. We need a deliberate separation of duties across three machines to protect our critical emergency operations from the heavy traffic of daily citizen apps. Machine 1 is your core server. It quietly handles the foundational stuff: identity, synchronizing data, keeping things stable. Machine 2 is your emergency ops. This is sacred ground. It runs the hotline, local maps, and incident workflows. It must never go down. And Machine 3, that's for daily ops: community chat, health scheduling, learning games. Why separate them? Well, imagine a heavy storm hits, and hundreds of citizens jump on the local chat to talk about it. If everything was crammed onto one machine, that chat traffic could literally crash the emergency hotline. By isolating these, we guarantee that a spike in everyday app usage never, ever compromises your emergency response. And the great thing is, your hardware capital expenditure completely scales depending on your population, land area, and terrain risk. You aren't forced into some one-size-fits-all box. The compact tier is strictly for small barangay hall pilots, but the moment you want real community operations, you move to the standard three-machine node. That runs between 180,000 to 320,000 pesos for the hardware. But notice how it scales up. A dense urban barangay doesn't necessarily need way more servers. It needs stronger Wi-Fi access points to juggle thousands of connecting phones. Meanwhile, a large, isolated mountain barangay needs the resilience tier, meaning heavy investments in outdoor networks, point-to-point links, and robust backup solar power. You fund exactly the infrastructure profile that your specific terrain demands.
Section 4. Daily value and readiness.
This brings us to the adoption engine of the entire system: daily use. This is exactly where a lot of traditional emergency systems completely miss the mark. Think about it for a second. If a parent can't check health schedules or a student can't access offline learning on a random Tuesday, they won't magically know how to use the network when a typhoon hits on a Friday. Emergency-only apps suffer from terrible adoption rates because people only open them when they are panicking. By packing Machine 3 with high-value daily tools like local games, brung announcements, health clinic workflows, we create muscle memory. The community gets used to connecting to the local PBV Wi-Fi every single day, so when the cell towers fall, they already know exactly what to do. The system earns its keep every day of the year. Now watch what happens under pressure. The system gracefully degrades, strategically limiting daily apps so that emergency response always has absolute priority.
On a normal day, step 1, everything is running. Chat, games, learning modules. But when an active incident occurs, say a severe storm is making landfall, the system shifts to step 2. It intelligently throttles those daily apps. And if things escalate into full emergency mode, step 3 kicks in. All non-essential apps on machine 3 are completely paused or turned into read-only advisory screens. Games disappear. Learning modules are replaced by emergency checklists. Literally 100% of the local node's computing power and Wi-Fi bandwidth is instantly reserved for the hotline, the command dashboard, and live incident mapping. It's a brilliantly self-managing prioritization of resources.
Section 5, Digital Utility ROI. We have to talk about the financial sustainability of this platform, which means shifting from traditional procurement to a managed service model. Because deploying hardware, that is only day 1. Day 2 through day 2000 is where these systems either thrive or they slowly die from neglect. That's exactly why we use a zero CapEx utility model. You aren't buying a static software license, you are subscribing to an active resilience utility. There's zero upfront cost for the software license itself. Instead of a massive multi-million peso software procurement headache, the LGU or a private sponsor simply pays a monthly service fee. This gives decision makers and auditors complete clarity. You aren't paying for an isolated app. You're paying to keep an entire local digital hub fully supported, updated, and ready. The hardware is a one-time CapEx, but the software ecosystem runs as a clean, predictable OpEx utility. So what does that actually cost? For just PHP 5,000 per month per active node, the OpEx is fully covered for monitoring, updates, and preventing the abandoned tech graveyard. To put that into perspective, that's roughly 166 pesos a day. For that, a barn guy gets ongoing configuration support, security patch guidance, technical troubleshooting, and system updates. I mean, how many times have we seen LGUs buy expensive technology only for it to sit broken in a corner 2 years later just because an update failed or someone lost a password? This 5,000 peso fee is your literal insurance policy against that exact scenario. It guarantees that the system remains a living, breathing asset that works flawlessly when the sirens sound. When you look at these benefits, you start to realize the true ROI of this system isn't profit. It's avoided failure. It's the absolute guarantee of operational continuity. For an LGU, ROI means a barangay health worker efficiently scheduling maternal checkups without eating up their mobile data. It means when a landslide blocks a major road, a structured situation report, or SITRP, instantly syncs up to the city command center the very moment any connection is established, rather than relying on a frantic static-filled phone call. It means continuous readiness, stronger coordination, and massive strides in local digital inclusion. That is value you simply cannot put a traditional price tag on. So what is the cost of not having maintained local digital coordination when the next emergency occurs? I'm going to leave you with that final thought to consider for your own community's readiness and resilience strategy. The real financial debate here isn't whether a managed service fee is affordable. It's about honestly assessing the devastating cost of being blind and disconnected during a crisis. It's about the cost of delayed responses, fragmented information, and ultimately failing to serve your citizens when they need you the absolute most. Project Bantay Bayan isn't just a software platform. It is a fundamental shift in how we secure and empower our communities from the ground up. Thank you so much for joining me for this explainer. Start planning your local node and stay resilient out there.